Welcome children. Now we can once again we can go through this lesson light. Here you see first of all how we see an object. To see an object, light from the object when it reflects and that falls in our eye, we can see that object. First of all, you know what is actually light, then how we can see an object. Light means an electromagnetic radiation, and that electromagnetic radiation that can travel through any medium if it allows to pass through it. Now, light when falls on an object and when it returns or reflects from it, and that light when it falls in our eye, we see that object. What actually mirror does? Actually, mirror reflects light. That means mirror changes the direction of light when it falls on it. What the mirror do? Mirror changes the direction of light that falls on it. Now, you want to remember about what is actually incident ray. See, this is a plain mirror, and this we draw a normal to this mirror. And a light that falls on this, here the light falls, and the light which falls on this surface, that is called incident ray. The light that falls on this surface is called incident ray, and this light returns from this surface, and this one is called a reflected ray. That means incident ray means the ray of light that falls on the surface, and the ray that is returned from the surface, that is called a reflected ray. Now two rays, one is incident ray and second one is a reflected ray. Incident ray and a reflected ray. See, this is the normal. The angle between this incident ray and normal. See, this is the angle between incident ray and normal, and this angle is called angle of incidence. That is, angle of incidence is I. And this one is the reflector ray, and this is the normal. The angle between these two is called angle of reflection R. That is angle R. Now you want to know about incident ray, reflector ray, angle of incidence and angle of reflection. What is actually a ray? Means a narrow beam of light. Ray means a narrow beam of light. Even though in a narrow beam of light there are so many light rays, then also we consider a narrow beam as a ray. See, now here incident ray, reflected ray and normal, angle of incidence and angle of refraction. Connected to this, there are two laws of reflection. Which are the two laws of reflection? First of all, see this incident ray reflected ray, then normal on the surface of reflection. that are lying in the same plane. lie in the same plane. Which are the incident ray, reflected ray, normal, which lie on the surface of refraction at the point of incidence that are lie in the same plane, and which is the first law of reflection. Which is the first law? Incident ray, reflected ray, and normal that are lie on the same plane. So that one is the first law of refraction. And second one is, this is the angle of incidence and this is the angle of refraction. There is angle of incidence equal to angle of reflection. That is, angle I is equal to angle R. This is the second law. That is, angle of incidence is equal to angle of reflection. That is, angle I is equal to angle R. This is the second law of refraction. Okay, now you can remember these two laws. Now see, next one is about can you remember about image formed by a plane mirror? The properties of image formed by a plane mirror. What are the properties of image formed by a plane mirror? The image formed by a plane mirror is always same size as that of object, same size image. That image is virtual image. What kind of image is formed by the plane mirror? It is formed by virtual image. The same size image. Then that image is laterally inverted. Laterally inverted means left side of the object when seen in the mirror appears as its right side. That means left side of the object seen there as a right side. So it is laterally inverted. Then another one is that it is distance from object. Distance from object to mirror is equal to distance from image to mirror. Suppose the object is 5 meter away from the mirror, then the image it appears also 5 meter away. That means the distance also remains same. These are the properties of image formed by a plane mirror. What are the properties? The image is same size as that of object. Then the image is virtual. Then laterally inverted. Then distance from object to image is same as that of distance from object to mirror is equal to distance from mirror to the image. These are the properties of image formed by a plane mirror. Now you want to remember about that means we already discussed these are all things. So this class is only about the revision of that unit. So you know what is regular and diffused reflection. What is actually regular and also diffused reflection? See here, this is a rough surface. Suppose on the surface of our bench. Now see here, this surface is not even. That means not polished down. Here when light rays, see light rays here falling. These light rays are the see incident ray. here parallel. Incident rays are parallel here. These incident rays are parallel. But you see, when there is a reflection, this is the reflector ray. See, here the reflector rays are not parallel. Reflector rays are not parallel in this case. This kind of reflection is called diffused reflection. Diffused reflection. In the case of diffused reflection, there is no image is formed. There is no image formed. Image formation in this case is not there. But here the two laws of reflection is correct. There is a incident ray, reflector ray, normal, that lie on the same plane. And also angle of incidence equal to angle of reflection. But we cannot get an image in this case because the reflector rays are not parallel. But you see, in the case of regular reflection, see reflection on the surface of a plane mirror. Here the incident rays whatever the incident rays is parallel. See the reflector rays here the reflector rays are also parallel in this case. So this can form image. Only in the case of regular reflection, there is image formation is happening. But in the case of diffuse or irregular reflection, no image is formed. No image is formed. But in both cases, there is the loss of reflection is correct or that is applicable. Now, see, this is the reflector ray. This is also a reflector ray. Here the reflector ray is parallel, but here no. Now the question is, can reflector rays again reflect? Is it possible to reflect reflector rays again? Yes. That is, we use in periscope. In periscope, we use it to mirrors in a particular way, so that we can see the object which we cannot see directly. The object which we cannot see directly, that we can see with the help of periscope. And also in kaleidoscope, by arranging three mirrors at a particular angles, we get a large number of images. Different patterns we get by using kaleidoscope and kaleidoscope. So in kaleidoscope and periscope, we use what is multiple reflection. What kind of reflection? Multiple reflection of light is used. In kaleidoscope and periscope, we use multiple reflection of light. Then you know what is about dispersion. Dispersion. What actually dispersion? Can you remember? Dispersion means suppose sunlight is passing through a prism. Here is only one light ray. But when this ray passes through the prism, see, we get a pattern of colors. That means in this manner, we get different colors from violet, indigo, blue, green, yellow, orange, red. This way, we get different colors. That means white light splits into different colors, and this phenomenon is called dispersion of light. But actually dispersion, the splitting of or separating of a light ray into different colors. And this phenomenon is called what is a dispersion. See here in the prism, here only one color light is incident, but from the mirror, from this prism we get 7 colors of the order: violet, indigo, blue, green, yellow, orange, red. And in this way, when light splits, we say that phenomenon as a dispersion of light. What it is called a dispersion of light. Then next we want to know what are the things inside in our eye. We know when we look to our eye, a white part outside, and that is very hard and nearly spherical shape. That hard part protects the parts of the eye inside. See, the front portion of the eye, a transparent front portion. Transparent means a part that allows light through it. Transparent front portion of the eye is called cornea. Transparent front portion of the eye is called cornea. And behind the cornea there is a muscular structure, black muscular structure. Black muscular structure, and it is called iris. See, first front portion of the eye, there is a transparent part which is called cornea. Behind the cornea there is a black muscular structure, and that is called what? Iris. And the color of the eye is actually the color of this iris. Some persons with a blue color means it is the color of that iris. In the iris there is a small openings. There is a small opening in the iris. And this called, and that part is called pupil. The front portion of that is front transparent part of the eye is cornea. Behind the cornea there is a black muscular structure called iris. And in the iris there is a, at the center of the iris there is a small opening called pupil. And light through the pupil is controlled by this iris. Amount of light that passing through the pupil is allowed by or controlled by what is this muscular structure which is iris controls. And then the light that is falls on the lens. That lens forms image of the object on the retina. Where does it form, sir? Image will form on the retina by the lens. There is a convex lens, and that convex lens forms image of the object in the retina. In the retina, see, there is a nerves, that is a large number of what is nerve cells. What is there? Nerve cells. In the retina there is a large number of nerve cells that sense the image formed by the lens. That is the nerve cells in the retina sense the image formed by the lens. And that image that is then sent into the brain by optic nerve. That means there is image on the retina, there is image on the retina, and that image is sensed by the nerve cells, and that nerve cells, that image is sent to the brain through optic nerve. Through optic nerve. There in the retina, there are two types of nerve cells. One cone cells. One is what is a cone cell. This sends bright light. That means the cone cells activated in bright light, and another one is the rod cells that activated in dim light. There is cone cells activated in bright light and rod cells activated in dim light. So these are the two types of nerve cells present in the retina, which are the cones and the rod. What is their function? These cone cells activate in bright light and rod cells activated in dim light. There is another important point you want to remember. There is blind spot. What is the term? Blind spot. The junction at which nerve cells and this retina, the portion where the optic nerves and the retina joins, at the junction where optic nerve joins to the retina, at the junction where optic nerve joins to the retina, there is no nerve cells. So vision is not possible at that region. Vision is not possible. Where we cannot see. That means at the junction where these optic nerves joins to the retina, there is no nerve cells. So we cannot get vision from that region. So that one is called a blind spot. What is called a blind spot? Now you want to remember the persistence of vision. Here 1/16 second. Suppose we see an object. When we see an object, its image retains in our retina for about 1/16 second. That long time, that means 1/16 of the second, object's image will retain in our retina. If we see another object within that time, we see that two objects together, and that is called persistence of vision. How long? Image will retain in our eye? 1/16 of the second. So if the objects move at the rate of 1/16 time, that is remain. If any object move at the rate of 16 images per second if getting, then what effect is getting means we see that object is moving. Even though that given object is still, if it is moving at the rate of 16 pictures per second, then we feel that one is moving. In film, the pictures are moving. See how many pictures? 24 pictures are moving in the sequence in 1 second. So we see that picture, that means in cinema, that it is moving. That means in movie, what actually doing is pictures at the rate of 24 per second is moving. So we feel that what is moving, that is actually happening. Now, to see an object, that object should be at least 25 centimeter away from our eye to get a clear vision. If we hold a book very close to our eye, we cannot read because we cannot get a clear image of that object. That minimum distance is called least distance of distinct vision, and for a healthy eye it is about 25 centimeter. So to get a clear vision, the object must be at least 25 centimeter from our eye. So the minimum distance is 25 centimeter for a healthy eye, and maximum distance for a healthy eye is infinity. Now see, there are different defects that may happen to our eye. Some persons can see near object clearly, but they cannot see faraway object clearly, and that defect is called short sight. But in other cases, some person can see distant object clearly, but they cannot see nearby object clearly, and that defect is called long sight. In some other persons, when they get older age, that is actually happening cataract. This cataract means their vision become foggy. This is due to the eye lens becomes cloudy. That is when the case of, that means when we consider the case of some persons when their age is become more, what happen, that means their vision become foggy. That means just like a fog, that means they cannot see the object clearly. The reason for that is eyelids. Their eyelids becomes cloudy. Their eyelids becomes cloudy, and that defect is called what is a cataract, and it can be overcome by replacing that what is a cloudy lens with a new one, that means by artificial lens. By using artificial lens, that can be overcome. This is the method. Now, what are the steps we want to take care of our eye? Care of our eye. Or, that means if there is any defects in our eye, then contact an eye doctor and wear the spectacles prescribed by him. Then another one is if there is any dust particle in our eye, wash our eyes with clean water regularly. Instead of this, don't rub to remove the dust particles from our eye. So wash our eye with a clear water regularly, so that our eye become, that is eye can overcome any kind of what is dust or other kind of particles. Then another one is do not look sun directly, because light from the sun is too intense. That means intensity of light from the sun is very high, so it can get a damage our eye. Then another one is not read in dim light. That also can damage our eye. Not read in dim light, that can damage our eye. Then another steps, that means read at a normal distance. That means not read very close or very large distance when we are reading. That means when we read, the book must be at a suitable distance so that our eyes does not get strained. That also we want to take care. Then, for the case of visually challenged persons, the most popular resource is for the visually challenged person, most popular resource is Braille system. Visually challenged persons which we use what is the Braille system. In the case of what is a visually challenged person, we use what is the Braille system. So what are the things we discussed? First of all, we discussed about light. Then, how vision is possible. Then, laws of reflection. Then regular reflection, diffused reflection, then multiple reflection, then in the periscope and the kaleidoscope we use this multiple reflection of light. Then came to what is inside our eye. The main parts, cornea, iris, pupil, lens, retina, nerve cells, optic nerve, cord cells, rod cells, blind spot, then we came to what are the steps for the protection of our eye. Then for the visually challenged persons, then brainy system. This much points you want to remember from this unit. First of all, light, then how vision is possible, then loss of reflection here. You want to remember incident ray, refracted ray, angle of incidence, angle of reflection. Then there are two types of reflection: regular reflection and diffused reflection. Then image formed by a plane mirror. Then multiple reflection, that is applied in what is a kaleidoscope and periscope. Kaleidoscope and periscope. What are the parts inside our eye? Which are the parts? Cornea, iris, pupil, lens, retina, nerve cells, optic nerve, cone cells, rod cells. Then there is blind spot. These things you want to remember about when you discuss about the eye. Then blind spot. Then also then blind spot. Then brainy system. This system is used for what is visually challenged persons. Where we use this one in visually challenged persons. Then about then how to protect our eye. These are the things we want to remember from this unit light when we go through the exam point of view. Okay, thank you.